Hey guys, this is second part of the Java construct. Let's see what we got. So previously we talked about these four topics: abstract class, nested class, inner class, and static nested class. And in this lecture, we are going to talk about anonymous class, and we will have an introduction to Lambda expression. We will get back to this Lambda expression later when we are talking about advanced Java. Okay, what is anonymous class? First, let's focus on what is anonymous. Yeah, it's a English word, and we know that it means no name, right? So, or hidden name, right? But the question is, have we seen this before? Oh, many times. Many times. Let me show you an example. For example, look at this println in Java. Look at this string. This string is not assigned to any variable, right? So it has no name. Yeah, a value has a name when we assign it to something, right? Since it is not assigned to something, so it is anonymous, all right? No name. Okay. So this is the general rule. Something is not anonymous when we can assign it to a variable. All right. Now the question is, what is anonymous class? So Java has a very special syntax for creating anonymous classes. Let me explain it via an example. All right. And the best example that I can mention here is our old animal game examples, those classes, right? So you remember these three, one cat class, one animal interface, and this was our code that we used here. So, for example, here we instantiated the cat, and then we passed this cat via a parameter here to be able to use this print voice. All right, we use this code for explaining the polymorphism. Okay, now let me bring up my Eclipse and start creating this example. Okay, let me create a new package for all of these stuff. So we are talking about nested. Let's call it anonymous. All right. Okay, so we would need the cat class. Uh, we already have that. Where was that? Let's see. Oh, okay, so we have animal interface here. Let me copy and paste it here. So, uh-huh. And also we would need our animal game that was here in the polymorphism. So animal game, probably it's easier to use this way. All right. And also we will need the cat class, and cat class is here. Let me bring it up here. Okay, so let's see what we got here. And we can organize them like this. All right, to be able to see them at once. And what else? We have the animal here. Okay, I'm gonna add it here. Okay, so now let's continue and see. what we are gonna do. Okay. So as you see, the cat is being used just once. All right. So can we use an anonymous class and pass it like this? Yeah, we can do that. We can, you know, remove this and don't assign it to a variable like this and just put it here as a new cat. Let me see how can we do that. All right, so let me get rid of this dog and cat, dog and dog. All right, so instead of here, I just copy this part and let me comment it out and this way. You see, very easily we can do that. All right, what else we got? And yeah, the other note here is if we want to call a method of this anonymously like this, we need to put this parenthesis here. You see here, and then just dot and get voice. Let's see how it works here. Yeah, for example, here, if I want to create, probably that's not a good place. Let me create another method, for example, here. Okay, so we want to use anonymously we want to call the cat like this, and then uh, we want to call the get voice like this. Yeah, but I don't recommend this. Look at this, the readability of the code is decreased, I believe. And whenever a readability of the code is decreased, I no, I don't recommend that because maintenance is a big deal, people. We need to keep an eye on the maintenance always. That's why the code must be readable. Was that the whole point that we were talking about? I mean, anonymous class is the thing that we saw in the previous slide? No, it was not. Yeah, the point is that we can define the whole class anonymously. It means that, for example, the cat class, we don't need to have a separate file for that. Uh, I am talking about in just in case, right? Not that particular cat uh, class. Sometimes we don't want to have a separate file for something because we just need to use it once. So in that case, Java has a special, syntax for this, right? So you can implement an interface, or even you can extend an abstract class anonymously. Let me explain by an example. So look at this. So this is the cat implements animal interface, and we have seen this many times so far, right? Okay, so now what is the syntax for anonymously creating and implementing this cat? Let me bring my Eclipse again. All right, so what do I need for these guys? I would need the animal game. Yeah, I have it here. All right, yeah, we have here. Okay, so now let me, um, instead of this, let me create yeah, I think it would be much easier and more understandable if I try to implement a cat, without having an external file for that. So here I would say, okay, I need animal interface, and then I want to implement the cat anonymously. How can I do that? Very easy. We say equal to, then new animal, and then parentheses. All right. So I can define the whole code here on the fly. We don't need any more to the cat class. All right. So now it is complaining that, okay, you are implementing animal. Okay, look at this. It is saying that, hey, you are implementing the animal interface. You need to implement everything. All right, we do that. Control 1, add unimplemented methods. Yeah. Yeah, it is saying that you need to implement this guy, the get voice. And yeah, it is right because, implementing this animal, we need to implement this abstract method. All right, so how we can do that? We can, just copy and paste from here to here. Yeah, all right, this way. Okay, so let's see what's the problem here. Okay, so it looks like that um, I would need to put it here, and then we have to get voice. All right, and let's see how many. Yeah, we will have one extra thing. Um, this guy, all right. So sometimes copy and paste, is doesn't work perfectly when we expect. So we would need one more here. Oh, all right. Yeah, we would need this guy. All right. Okay, so since this is from here to here is, one operation, we would need to terminate it with a semicolon. Okay, so now you have seen that how we could, you know, implement a new cat on the fly. So with this definition, we won't need anymore to the independent cat class. All right. So to show you that it works, so CVS, and we just call the print voice, and we would need an animal here, right? We just need to, uh, pass the cat. All right. Okay. So now let me see. Okay. So the problem that we have here, we still have that jar file. We should go to the build path and remove this jar file. All right. And so we would need now animal voice service. Okay, so we need to make a copy from here and put it here. All right. So we don't need this import anymore. Okay. So yeah, everything looks like good. And yeah, this import does not require anymore because we have this class here. All right. So let me finish what I said. Uh, we said that sometimes we need to have just, we use a class just once. We don't need to have a separate class for that. We can anonymously implement an interface on the fly, and That's what we did from here up to here. All right? Okay, let's see what we got here. Yeah, this is whatever I just explained. Well, we can do the same thing with the abstract class as well. All right? So look at this. You see here. So if we have the animal uh, abstract class, then we will see, we have exactly the same thing here. All right. Okay. So let me see. Um, do we have that abstract? Dog. No, here, not here. It was some here. It should be here. Yes, here. All right. So let me have a copy here. And all right. Okay. And we can do the same thing with the abstract guy. So let me, yeah, I just need to change this to animal apps and see what else we need to do. Uh, Let me remove this stuff. X and see what it needs. Um, okay, so we would need to have this. All right. Yeah, so yeah, we would need to, yeah, you do the same thing here, and then we are done. All right. And this complaint is because their code is based on so it's based on the animal interface, not animal abstract class. That's why it is complaining. So we don't care for now. Uh, yeah, and this complaint is why you are not returning anything. So we need to return the voice, and we need to define the voice here. Let's say string voice equal to what was that? Meow. Yeah, something like that. Okay. Okay, so now let's see what we got more. So what is the ingredient of anonymous class? An anonymous class can have instance variable. We saw that right now. It can have method. It can have other nested classes. Yeah, we don't want to complicate this more, but yeah, we noticed that this anonymous class, this guy from here to here, you see we have an instance variable, we have uh, method here, we can have other method, and also we can have another nested class that I do not recommend at all, but not bad that to know that it is possible. So let's say public class, yeah, in my inner, let's say, and okay, so what is it's the problem of this? Um, for the local is only abstract or yeah, that's the problem we have. All right, so if you have an inner class, let me show you here, it should be either final or it should be abstract. So the inner classes inside an anonymous class, if I put a final here, um, let's see, Hmm. All right. So yeah. Okay. So, but the other parts, I mean, the instance variables and the methods, they can have any kind of access modifier. So, for example, the public, yeah, default, and it was already, I think, protected, right? And also private, no problem at all. And you can check the method as well. Actually, not this method, right? Because it is overridden. It has, its own rules. Yeah, you just create another method and try to, yeah, yeah, look for here we have something here. Let me just copy and paste here. And yeah, you can check that all of the access modifier are applicable here. All right. Uh, okay, so here is the restrictions. So anonymous class cannot have constructor, and it makes sense because we are not gonna instantiate an anonymous class, right? They cannot have static members, but constants are okay. Yeah, a static member, uh, again, it makes sense because we are not gonna instantiate it, and it is totally uh, tied to the host object, right? So, for example, if we create this static, it doesn't make sense at all that uh, um, instance variable is in static based on the definition that we know from the static, right? But you can have a constant. What is the constant? The constant, it can be public, final, and static. Let's say, for example, x equal to 10, something like this. And all right, that's fine. Okay, so yeah, it needs all right. Okay, let's see what we got more. And yeah, this is the point that we saw in the previous slide. If you have a nested class, the nested class, it should be qualified with either final or abstracted. I believe it's a weird thing, but since we are not gonna use this kind of thing, this kind of complication about the anonymous class, so just we ignore that. Okay, now let me give you some notes about the anonymous class. So that override notation that you have seen here, so here, it was, mandatory before Java 8, but it looks like if I remove them, for example here, you see there is no complaint, but in Java 7 and older, yeah, it was a big deal. It gave you some, uh, red error. And also, using anonymous class is not recommended. Yeah, it's not recommended. Again, it decreases the readability of the code. All right. Okay, so that's what I had for the anonymous class. What is lambda expression? Okay, so let's see. Before going further, let's refresh our mind about some of the stuff that we learned before. For example, what was entity? So we said entity doesn't have any specific definition. It is a primitive concept. Everybody understand that, but we can describe that. Whatever it exists in this universe, physically or conceptually, conceptually means in our mind, for example, we call it an entity. Okay. And what was the paradigm? Paradigm is a way of thinking, a way of modeling and representing these entities inside our cyberspace. So paradigm in computer science is a way of modeling and representing what? The entities and the relationship between the entities. All right. Okay. What else we learn? Now we want actually to introduce a new term, functional paradigm. We mentioned that before, but we didn't you know you know delve into it. So now it's time to a little bit talk about that because it's a very related topic to the lambda expression. Okay, so what is functional paradigm? So since it is a paradigm, it is dealing with the entities, right? And the way that it looks like the universe is functions. It represents all of the entities in the universe by the functions, the entities and their relationship, right? So that's what we call functional paradigm. Okay, so in OOP or object oriented paradigm, we model everything with the objects, right? Okay, so now what is function? So function looks like a method, a regular method, but it always returns something. Method can just have a void as their return, but function based on the definition is a piece of code that it returns something. All right. And now the other question is what is functional programming? Functional programming is a programming or let's say those programming languages that claims that they support functional programming, they should have some feature. What feature? They should use functions as values. What does it mean? Using functions as values. Yeah, here is the definition. If you can if you can assign a function to a variable, if you can pass a function as a functional function parameter, and if you can return a function as a return value, these three places, if you can use the function, then we would say that programming language supports functional programming, right? And for example, in OOP, Java, you know, support all of these three things for the objects. Yeah, we can assign an object to a variable, we can pass it, we can return it, right? All of these three feature we have for the object. So that's object-oriented programming. But you know that after learning the fundamentals, that four fundamentals of the object-oriented programming, we know that object-oriented programming languages should support those four features as well. All right, let's get back to our functional programming. Let me summarize what I said here. So if we can consider function as a value, then we would say our programming language support functional programming. And what are, when we can say function can be considered as a value, when we can do these three things. Yeah, these three things, if we can do, then we would say, we have a functional program. All right. So now let's get back to lambda expression. All of these, whatever I said so far was an introduction and required background or refreshing mind to be able to understand lambda expression. Now, uh, the question is, um, actually, the fact is that in Java we can assign values to variables. Of course, we can do that. For example, this is a string, yeah. This is just an integer, and this is an object. Yeah, it's a we instantiated the class and created an object. So and we can assign them to variables. But the question is, in Java, can we assign a piece of code to a variable? Can we do that? So why I am asking this question? Because I am looking for the possibility of functional programming in Java. Yeah, if we can assign a piece of code to a variable, then possibly we might have a functional programming in Java. Okay, so let me take an example here. So here, look at this. We assign this piece of code to this variable, and we have a type here that we still don't know what it is, right? Let's call it a type, right? Can we do that? Yeah. If we say yes, then possibly or probably we will have functional programming in Java. Okay, the reality is before Java 8, we couldn't do this, right? But after Java 8, they added some features that we called it Lambda expression. I explain it in detail in the next slide. So then, they added the functional programming features to Java. Now, Java after Java 8 is object-oriented programming language, but on the side, it is a functional programming as well. Let's see how. All right. Okay. Okay. So I said here that uh, we can do that, but not in this way. The syntax is not correct. But I'm going to walk you through a step by step to discover the syntax, the syntax that currently Java is, supporting. All right. Okay, so the first thing that we would need to remove here is that public. That public is meaningless, right? What is this public here? If we are going to, excuse me, if we are going to assign a piece of code to a variable, then, why should we say that it is public? Yeah, whenever you have this name, this variable, you can use that piece of the code. So absolutely this public is a redundant thing, right? We just remove that. Okay, so what we got here? Yeah, this guy. Okay, what else? The void or return type is again redundant. Why? Because JVM nowadays is very, smart. It can figure out that what is the return type, right? So yeah, we can remove that void as well. And we got here. What else we can remove? The name. So this name is redundant too. What is this? The name from now on will be this, right? So we don't need this print hello world anymore. Yeah, let's remove that as well. So what we got like this. Yeah. Okay, what else we can do? We are still discovering the syntax, right? Okay, so between this, so this is the syntax Java syntax specific for this kind of lambda this expression. Okay, so between these parentheses and this curly brace, we would need to use this symbol. It's a dash and a, let's say, greater than. All right. So here what we got. Okay. So you see, we pruned and we cut whatever we really didn't need, and now we ended up with this syntax right now. All right. Okay. And another pruning would be that curly braces. If our code is just one line, we can remove that curly braces as well. But if it is more than one line, we need those curly braces. All right. Now we got this. So you see, very simple syntax right now. Okay. Okay. So now let me ask some question. Up to this point, we have a lambda expressions that we don't have any argument, and yeah, it's just one line. It's not a big deal because if it is more, we just return back those curly braces. But here, in our example, we didn't have any argument. Okay, now the question is, if we have argument, what should we do? Right? More, one or more arguments. And also, what the heck is this a type? We still didn't talk about that. Yeah, yeah. So in Java, you know that every variable needs a type. Java is tightly, very strictly type system. All right. Okay, so we would need to, clarify these two questions, and I'm gonna explain, via examples. Okay, so here is uh, a very simple example. We have an adder here, and in this adder we pass two a and b, two parameters, and we just return the summation of them. So it's very simple. So if you apply all of those things that we said in the previous slide, and we get something like this, right? So these are the arguments, and this is the that return. And since again it is a one line code, we remove those curly braces. Okay. Another pruning that we can do is removing this return. Why? Because as I said, JVM, Java Virtual Machine, is so smart nowadays. It can figure it out that when you put something like this, you mean returning that value. So that return can be removed as well. So, all right. In this slide, we responded to one question. If we have parameters or arguments here, then it looks like this. And also, we learned that we can remove that return because JVM can, figure it out by itself. Okay, but there are more pruning, right? We can, make this final thing even simpler, right? All right, so let's see. Okay, so now let's get back to our second question. What is this type here, right? Okay, as we said, in Java, we would need a type for every variable. So what is the type of the lambda expression? That's a very, important question. Okay, so here is the reality. So Java uses interface for the type of lambda expression. Very interesting. Again, we see the footprint of the uh, interfaces. Yeah. So interface is the type for lambda expression. All right. But the point here is it's not the case that every interfaces, any kind of interfaces, the interface should have a very specific feature. The interface should have one and only one abstract method, right? This is the only restriction that we have for lambda expressions. So if you want to use an interface for a lambda expression, you need to create an interface that it has one and only one abstract method. And these kind of interfaces have a specific name. We call them functional interface. All right. So let me officially define this in the next slide. So what is functional interface? It is an interface that has one and only one abstract method. All right. The point here is these kind of interfaces, I mean the functional interfaces, they can have other ingredients. For example, they can have constants, they can have default methods, they can have static methods, right? But they should have only one and only one abstract methods. So, the other things we don't care, but this one and only one is a very critical thing here. Okay? Yeah, let's continue our example right now. All right. So yeah, let's get back to this a type. So we were talking about what is this a type. Okay. So now we know that we need an interface, right? So what that interface look like? It can look like this. Look at this. So its name should be the same thing here, right? And then we have one abstract method here. And that abstract method, of course, it should have the same, signature, right? The same, we don't care about the name, but, these arguments should be the same and the return value should be the same. So it is more than the signature. Actually, we cannot say signature because signature is a specific, name because the name is important in the signature. But let me summarize what I said. The interface, the functional interface for our example like this, it should have the same arguments and the same return value. All right. Okay. Okay. Before going further, let me show you a quick demo about this. So let me create a new class. Let's call it, for example, Lambda demo. All right. Uh, for our interface, so we need a functional interface, right? A type. Let's call it a type to be consistent with uh, the lecture note. Okay, so for simplicity, I want to create it here. Yeah, interface. Let's call it a type. And a type will be a functional interface, and it would need one uh, let's call it add one abstract method, and the parameter is int a comma int b. Let's see, got it right? Yeah, you see here. All right. Okay. So how can we use that? Uh, Let me create a main method here, right? And okay. And here is our, let's call it adder equal to. Okay, so how can we implement this lambda expression? Look at this. This would be int a, int b, and then lambda expression and return a plus b, and that's it. Okay, so this is a functional interface. Let's see, for example, if you want to add a static thing, I'm gonna check the restriction we had. So, for example, if we make it static, it will complain here, right? And we can have a constant here. That's fine. Let's say public final static. Let's say a string name equal to Tom. That's fine. And also, and we can have a default method. Let's say void a method here. Yeah, no okay, so that's the void. So no complaint again. And also, and the other one would be an static method that, yeah, let me just remove this. And again, there is no problem here. Okay, so now let's see what we got here. Okay, so we have some note here. Some cases, uh, let's say you created this functional interface, this guy, and since we said that we need to have only one and only one abstract method here, right? Okay, so let's say you have a very big project and you created this interface, and what would happen then 3 months later, you will be assigned to something else, and the other guy will come over and take over this code. And probably he or she does not know that this is a functional interface, right? And maybe, they add another thing. Let's say, for example, let me create one more. Let's call it add two, for example, right? Now you see this guy is complaining because it's not functional interface anymore. Okay, so to prevent this happen, we can use an annotation that we call it here. We put it here. So it is functional interface and annotation. So let's see, functional interface, this guy. Yeah, you can put it. Yeah, it's complaining that it cannot. Um, yeah, the complaint is that it. Oh yeah, we added in the right, no, wrong place. So we should put in the the name of the interface. So its job is, if you add something else here, if we add something else here, let's say for example 2 here, again it is complaining. It doesn't let you move on, right? So, yeah, putting this guy will guarantee that the next developers won't make such a mistake and they don't break the code. All right. So this was the point number one. Actually, this is the only uh, point here. All right. The next thing that we want to talk is type inference. So what does it mean? It means that uh, JVM is smart enough to figure out about the types. So we don't need even to put the type of the arguments of the lambda expressions. What does it mean? Yeah, look at this. So when we have this interface here, and when we have this type, which is a mandatory thing here, then we won't need to put the type here because JVM can, infer that from the looking at the interface. All right. So we can just remove even the type of uh, the arguments. Yeah, let's see here. Yeah, since we have these types here, we don't need these types here. So you see how, very small and very concise code we will have for the lambda expression. Okay, we still have more pruning. We can prune more. So if we have only one argument, then even we can remove that parenthesis as well. So here we had, two arguments, right? If we have only one, then even we can remove that. So removing the parentheses. Let me see. For example, here, just let me add one like this, and let me say, for example, it is multiplier. Okay, so let me see what is the problem. Yeah, the problem is because it's using this guy, so we would need to have one here. Now there is no problem here. And also, yeah, I wanted to say that, yeah, this is, let's call it doubler, double everything. Yeah, if we have just one, we can even remove this parenthesis as well. Okay, so this is the example I just showed you. All right, now the question is, how can we call a lambda expression? So here is an example. The interface, we called it myAdder, and here we instantiate actually we would say we created this lambda expression like this, and then we want to use it. So from now on, this variable contains this function, right? We can pass, the parameters to the arguments, and then we receive the addition. All right. So here is how we can call it. It's exactly like the regular objects caller. So look at this. So this adder, this is this variable, and then we call the method. This method is coming from this guy, the interface, and then we pass it 2 and 5, and we will get this probably 7. All right, let me show you here. So to be consistent with uh, the lecture note, let me create this interface. So this will be the add, and let me again put it here, and the type will be myAdder, and here we will have myAdder. So this is just adder, and here we return the, okay, like this. All right. Okay, so how can we call it? So let me call it exactly here, and We said, yeah, we just say adder. So look at this, from here to here is a lambda expression, right? And we assigning it to an interface variable, right? So this guy should be an object. In object-oriented, everything is object. So a lambda expression, ultimately will be an object and will be assigned to this. So either I just type a point, you see, it will give you all of this stuff. So we want to add, yeah, we want to add, and let's say, for example, 2 and 5. Okay, to show that it is working correctly, let me just print it, right? Like this. Okay, so let me see, run it as a Java application. Okay, so there are some errors in some other places. Um, okay, there are, a lot of errors we had. I mean, we changed the code a lot, and all of these inside um, one project. That's why it doesn't, let me to run it. So I will, fix this later. Okay, to save some time. So we learn how to uh, call a lambda expression. All right, all right. So here I explained that a lambda expression, everything actually should be an object in Java. Okay, now here we want to compare lambda expressions and anonymous classes. So anonymous class, we learn how to implement an interface, and also how can we extend an abstract class, right? And lambda expression, we saw that it's a piece of code, right? And yeah, it's a piece of code, but the type will be an interface. All right. So if this is the interface here, yeah, the same my adder, okay, we learn how to implement that via an anonymous, implementation. Okay. So this is the way that we implement on the fly as an anonymous class. All right. Now we want to, do the same thing with the lambda expression. Okay. So this my adder, the adder, this is the same thing that we saw in the previous slide, right? So what was that? This guy. Yeah. Yeah, exactly. They are the same thing. Yeah, you just compare this and this code. This, the anonymous class is very verbose. There are a lot of code, but Lambda expression is so concise. Yeah, we love this, definitely. All right. Okay, so what benefit we get from the Lambda expression? So first of all, it enables us to add the functional programming into the Java. And we learned that it's very concise, very fewer line of the code, and it is very readable if we get used to it, of course, right? And also, it is, the benefit for the Lambda expression. It gives us this benefit that we can use parallel processing or multi-threading, better and easier. It supports a great, parallel processing, and also the efficiency is higher. Yeah, the efficiency of the lambda expression is higher because we can use the multi-core CPUs. Actually, these are beyond the scope of this course, but not bad to know about this. All right. So Lambda expression, as we said, functional programming to Java, which is a very, huge breakthrough. So Lambda expression was introduced, since Java 7, and really it was a breakthrough because, adding a new paradigm to a programming language is a, big deal, right? So so we can, even though we didn't see some, examples, all of the examples we have seen was, for assignment statement, but we can do, we can pass a lambda expression via as a parameter to a method, and also we can return a lambda expression from a method, right? So because of this, and it means that we have functions in those three places. So it means that Java can consider the function as a value because it can assign it to assignments, a variable. We can pass it via a parameter of the method, and we can return it. So because of these three features, it means that functions for Java is a value. And because of this, it means that Java supports functional programming. All right. So that's what I had for Lambda expression and anonymous classes. I'm gonna stop here, guys, and see you in the next lecture.